Hey everyone, today we're going to start learning about simplifying radical expressions. Yesterday we talked about our perfect squares, so hopefully you see this list across the top of the first page and you know what to write. If you want to take a second to write them down and pause the video, you can, but otherwise I'm going to go through the answers really quick. Square root of 16 is 4, square root of 25 is 5, square root of 9 is 3, square root of 4 is 2. Square root of 36 is 6, square root of 49 is 7, square root of 64 is 8. But as we kind of talked about yesterday, not all numbers have nice results when we take square roots of them. For instance, if you type square root of 45 in your calculator, you'll get approximately 6.71. If you type in the square root of 12 in your calculator, you get approximately 3.46. And if you type in square root of 125, we get about 11.18. We're not going to be rounding square roots today. We're going to be asked to give our answers in exact simplified form. That means no rounded decimals. So we're going to figure out how to do that. A little bit of vocabulary for us. Please write this down. Sometimes there's a number right there. That number would be called the index, and we'll talk about why we don't see a number there for this picture. I'll write it over here if you want to see an example. So something like this, we would say it's the fourth root of 16, and it has an index of 4. This part, that the top arrow on the right, is called the radical, and the number under the radical is called the radicand. R-A-D-I-C-A-N-D. If there is no number written for the index, kind of like we see in our example typed for us, it is implied to be 2. Means even though if we don't see it, that means it's a 2. And our specific name for an index of 2 when we're taking a radical is a square root. We are familiar with that. So, radicals are simplified when the radicand has no perfect square factors other than 1. So that's one thing we have to look for. The radicand has no fraction, so no fractions underneath the square roots, otherwise it's not simplified yet. And finally, there is no radical in the denominator of any fraction. We won't be talking about that today. That'll be next week. So, multiplication property of square roots. If you have the square root of 2 numbers being multiplied together, you can separate those square roots into 2 pieces. Let's see one of those at work. Square root of 72 here at the top of page 2 is approximately 8.485. It's not a perfect square. But we do know that 72 is 36 times 2. And why do we want to break it up with 36? 36 is a perfect square. So there's a reason why we're doing that, okay? We're looking for perfect squares, kind of like that first part of the bottom of page 1. The radicand has no perfect square factors, so we're looking for perfect square factors. So we could write the square root of 72 as the square root of 36 times 2, which we can break up into 2 pieces. The square root of 36 times the square root of 2. And we know how to simplify the square root of 36, or at least you did it at the top of the last page. The square root of 36 is 6, no more radical. The square root of 2, however, does not have a nice answer. And if we're not rounding it to a decimal, we kind of have to just leave it as is. So our estimated value for the square root of 72 is 8.485, but our exact answer is 6 root 2, 6 times the square root of 2. If you were to go to your calculator and type in the square root of 72 and to type in 6 times the square root of 2, you would see that it's the same number. This 6 root 2 is our simplified radical form. So how do we do this? You are looking to divide the biggest perfect square, that you can out of all these numbers. If you have that third sheet of paper, or that sheet of paper that I cut into thirds that we made that table on yesterday, that is going to be super helpful. I'm going to write it down on the side of my paper here. And we're trying to figure out the biggest perfect square factor of these numbers. So I'll go up to 15 squared. So 121, 144, 169, 196, 225. Okay. So when we look at 28, factors of these numbers, kind of like when we were factoring, they have to be smaller than 28. So if we looked at our perfect square list, the numbers that are smaller than 28 are 25, 16, 9, 4, and 1, but we don't really care about 1 because the square root of 1 is 1, and that doesn't really help us simplify anything. Now, I'm hoping that you can tell from that list of 4 numbers which one is the biggest one that divides into 28, but if we don't know, you could go to your calculator. You can go 28 divided by 25, which is a decimal. That's not a factor then. You can do 28 divided by 16, which is a decimal, which means it's not a factor. You can do 28 divided by 9, which is a decimal. It's not a factor. But if you did 28 divided by 4, you get 7. So 4 is a perfect square factor of 28. So we're going to write 28, square root of 28, as the square root of 4 times 7. And we're going to break that into 2 pieces. The square root of 4 times the square root of 7. Now, 7 doesn't have any perfect square factors. If you look at this list over here on the right-hand side again, the number that's smaller than 7 that could divide into it is 4, and you get a decimal. But when we simplify the square root of 4, what is the square root of 4? I'm hoping you're saying 2. And then it's times the square root of 7. And that square root of 7 we cannot simplify anymore because it doesn't have any perfect square factors. So, to write our answer as an exact value, we would say that the square root of 28 equals 2 times the square root of 7. If you think you've got it, pause the video really quick, try 2 and 3. If you don't know if you got it, I'm going to walk through them now and you can follow along. But if you think you got it, you should pause and try the other 2, see if you get them right. So, 44. What are the numbers that are smaller than 44? Looks like we're going to add 36 to the list. And again, if you need to go through this the long way, you would try, like I would type in the calculator 44 divided by 36, but that's a decimal. 44 divided by 25, that's a decimal. 44 divided by 16, that's a decimal. 44 divided by 9, that's a decimal. 44 divided by 4, though, that's 11. So we could take the square root of 44 and write that as the square root of 4, our perfect square, times 11, which we could then separate into the square root of 4 times the square root of 11. And we can simplify the square root of 4 because it's a perfect square. The square root of 4 is 2. Now, why are we done here with 2 times the square root of 11? Because if you look at 11 and you look at our list of perfect squares, 9 doesn't divide into it, 4 doesn't divide into it. So our final exact answer is 2 square root of 11. Now, this can get a little tricky when the numbers get really big, like 405. That's fairly large. All of our numbers currently on our list are all smaller than it, so technically we would have to try dividing all of them. In fact, there might be bigger numbers on our list that we could divide by, but I'm also going to give you a hint here. You will never find a number that divides into any of these numbers that's more than half of that number. So when I look at 405, half of it is 202.5. So I know anything bigger than that number will not be able to divide it nicely and give you two integer factors. So we're going to start at 196. If you type that in your calculator, you get a decimal. 169. 405 divided by 169 is a decimal. 405 divided by 144 is a decimal. 405 divided by 121 is a decimal. 405. It's not divisible by 100, but 405 is divisible by 81. It's 5. So we're going to take the square root of 405. Oops, sorry about that. And we're going to use the fact that 405 is 81 times 5 to break that up into two square roots. Square root of 81 times the square root of 5. We're hunting for these perfect squares because square root of 81 has a nice way to simplify it. What is the square root of 81? That is 9. Square root of 5. Can we simplify that any further? We think about our perfect squares. Is 5 divisible by 4? It's not. So it looks like we are done. Oops, I keep hitting the undo button. That's my bad. So, the square root of 405 simplified is 9 times the square root of 5. All right. I'm going to have a second video to watch. It's going to go through how to work with the variables and then a couple practice problems.